All right, today we're tackling something that's at the very heart of Swift, structs versus classes. And look, this isn't just some dry technical detail. We're really talking about two totally different philosophies, two different ways of thinking about how data should even work in the first place.
So let's just boil it all down to one single question, because this is really what it's all about. When you copy a piece of data, what do you expect to happen? Should you get a brand new, totally independent duplicate? Or should you just get a second label that points right back to the original? The answer to that question changes everything.
So first up, let's talk about structs. Their whole world revolves around one core idea, the philosophy of copying. You could think of it like making a photocopy. Every single time you pass a struct around in your code, you're getting a fresh, clean, totally independent copy.
And that's exactly why we call structs value types. You see it right there on the screen. Each variable holds its own separate, independent copy of the data. Once that copy is made, that's it. It's yours. It has absolutely no lingering connection to where it came from.
To really see this in action, we're going to use this super simple blueprint, a point struct. All it does is hold an x and a y coordinate. Nothing fancy. This will be our little test subject.
Okay, let's walk through this. Step 1, we create our first point, P1. Easy enough. Step 2, we make another variable, P2, and we assign P1 to it. Now, here comes the magic moment for structs. In step 3, Swift doesn't just link them. Oh no, it makes a brand new, totally independent copy of that data and gives it to P2. They are now two completely separate things.
All right, time for the experiment. We're going to mess with the copy P2 and only the copy. We're changing its x value from 9 all the way up to 99.
And bam! This is the payoff. Look at the outcome. The original P1 is completely untouched. Its x value is still 9, just like we left it. But the copy, P2, well, it's been changed to 99. The change was totally isolated, completely contained.
So what's the big takeaway here? With structs, every variable owns its own little island of data. This makes your code incredibly safe and predictable. You make a change over here, and you don't have to worry about some weird side effect happening way over there. That's why they're perfect for things like data models, coordinates, or simple configuration settings.
So that was the philosophy of copying. Now let's flip the script and explore a completely different world, the world of classes and their philosophy of sharing.
You see, classes are what we call reference types. Instead of making copies, different variables can all point to or refer to the one and only single instance of data in memory. So forget about photocopies. This is more like sharing a link to a single Google Doc. Everybody's looking at and editing the exact same thing. And check out our blueprint. The only thing we've changed is one little word. We swapped struct for class. It's a tiny change in the code, but it's about to cause a massive change in behavior.
We're going to run the exact same test. Step 1, create P1. Step 2, assign it to P2. But now, pay close attention to step 3. Because this is a class, no new copy is made. Instead, P2 just becomes another name, another pointer looking at the exact same point object that P1 is already looking at.
And just like before, we're going to run the same experiment. We'll change the x value on P2 to 99. So, knowing that P1 and P2 are just two names for the same thing, what do you think's going to happen to our original P1 this time? And there it is, a totally different result. We changed P2, but look, P1 changed right along with it. They both now show an x value of 99. Why? Because they were never two separate objects. They're just two different labels for the exact same thing.
Okay, so we've seen both sides of the coin in action. Now, let's put them side by side in a direct head-to-head comparison to really let this sink in.
This table just lays it all out perfectly. You've got the fundamental type difference, value versus reference. That directly leads to their copy behavior. Structs make a new copy, classes share a reference. And that, of course, changes how mutations work, affecting only the copy or affecting all the references. It all rolls up to safety, where structs are super safe by default, and classes, well, you gotta be careful. And that tells us what they're best for. Structs for independent data, classes for a shared state. So, why does any of this matter? I mean, really, what's the big deal? Well, let's get into our final section, the architect's decision.
You know, this isn't just some nerdy little detail for programmers to argue about.
This single difference between making a copy and sharing a reference, it drives massive architectural decisions. Choosing between a struct and a class fundamentally changes how data flows through an entire app.
So we end right back where we started, with that same question, but now we get just how much is writing on the answer. As a software developer, do you need a private, safe, independent copy, or do you need a shared, single source of truth that everything can see and modify? The stability, the speed, the features of the apps you use on your phone every single day, they all depend on developers making this one choice correctly, over and over again.